Hi, I'm Martin. I'm very happy to be here to talk to you about front-end rendering performance. I'm head of engineering at Archeologic, which is a small startup or company from Zurich. We are 17 people, I think, and we are building these wonderful 3D editors. This is in your browser, so that works on your phone, tablet, computer, whatever. If you have a really old Nokia phone, maybe it's not working that well, but if you have a more or less recent phone, then it's fine. You can create these tours, you can create these floor plans, you can change furniture, all that kind of stuff. And as we work a lot with 3D, we had to get into really like the nitty-gritty details of how browsers render things, not only in Webgl, but also in regular web applications. So, oops, what was that? So yes, I am Geekonaut on Twitter. If you have any questions and are too shy to talk to me, that's perfectly fine. Just tweet me. I'm happy to answer all your questions. I'll be in the discussion zone, so if you're not too shy to ask questions later on, I'm happy to take your questions there as well. And generally, I love if people talk to me, so that if you have some questions or you want to share something that you do, definitely reach out to me. Also, our tool is free. You can try it out, whatever. So today we're going to talk about how we are taking text to something visual. So that's a parsing effort, right? We're starting with a bunch of markup, and then at some point we end up with pixels. But how does that actually work? And I know that this has been marked as a hardcore session, but I try to make it as easy as possible to also get into it, but you should know some JavaScript and you should know some CSS, and HTML should be something that you definitely are fine with putting on your CV. So first things first, we're going to talk about how does a website actually load? Well, the first thing is that we have to get to a server and get this text, which is the HTML, CSS, and JavaScript markup and language code. We have to get that from a server. So we are fetching that from, we are starting with HTML, we are fetching that from a server over the network. Then we have a bunch of text. Cool. So now the next thing is, well, we're going to tokenize this. What does that mean? Well, we're going through HTML and basically breaking it down into the HTML elements and tags, and then kind of go on further with that. So now, this is interesting because unlike JavaScript, it kind of like has to download in total first, and then you can only start evaluating it. HTML, as it is basically a tree structure, we can evaluate it the moment we have a complete element. So we are basically doing it as we kind of receive it, so that's called a streaming parser. Once we are having a bunch of these tokens, then we can create objects from them. And these objects are basically a tree. So you have your document. In your document, you have a headline, for instance. In the headline, you have a bunch of text. Next to the headline, you have an image. In the image, you have a certain, picture that's going to be displayed, and so on and so forth. So we are parsing this into a tree. But we not only do this for HTML, we also do this for CSS. So we're having two trees. The DOM tree you probably have heard of. What you might not have heard of, that this thing also exists for CSS. It's called the CSS-OM, the object model tree for CSS. We're parsing these tokens into these trees, and then we basically have a bunch of objects, and we know how large these objects are going to be, and then we can start actually putting them, like laying them out. So this goes here, this goes there, this is too large, so it goes on its own line, and so on and so forth. This is called layouting. Once we have layouted the page, the next thing that we're going to do is we're going to actually have to make these boxes of things that we haven't yet had a look at. We have to make them actually exist, right? We have to paint in the colors, the pixels, and then we have a bunch of these boxes, and we have them painted. They are all colorful and wonderful, and now we have to put them together to make a page. That's the process. Okay. Now let's have a look at what we can do after this process has done, because we have JavaScript. And with JavaScript, not only we also have CSS. CSS can also change things around, but with JavaScript, we can be a party pooper and say, that's very nice how you laid all this out, but how about we move this over there, right? So we can get more dynamic on the page than that. So let's start with parsing. Anyone have any idea what application this is, by the way? What mail? This is Gmail. What gave it away? Huh? What makes you think this is Gmail? Weird classes, yeah, because Gmail is the only thing that uses weird classes. But it's correct, this is Gmail. So how do we parse websites? So I said it, so basically parts of the text come from the network. So here we have hello holy.js, and this is actually a complete element. So the browser goes, wait a minute, I have two things here. I have the headline element, so that's one thing, and I have a text node that is inside that. Okay, cool, so I have the h1 element, I have a bit of text, and then there's a paragraph coming in that also has a bunch of text, and then another paragraph comes in and that has an image inside, and so on and so forth. So basically the browser goes, okay, so I have these things now, and I have my body, and in the body I have the h1 element, in the h1 element I have some text, then I have a paragraph, some text, and I have another paragraph with an image. So we are building this tree. And we can do this as we go along because we're receiving things, right? So we can basically do this in parallel as we are receiving the content. And then we might have a look at some style sheets. So here we have an external style sheet, and then we have some inline styles as well. And the problem with the external style sheet is that we have to download this before we can do anything about it. So this is a bit annoying, but okay, so now we wait, and at some point the styles come in, and then we can go through our style sheet and we can say, okay, so the body shall have a red color, and then we basically color our tree in. So now that we have colored our tree, we can go to the next style rule, and we can say, okay, h1 shall be blue, so we are making that happen. And then maybe we have this one that actually colors it green. So basically, as we discover the tree, we can build this CSS object model, and we can kind of like prepare our styles for the tree. Sweet. So this is how this looks. So this is what we have right now. But we are not rendering this, right? This is not how your websites look like when you open them. So the next thing that we have to do is, well, first some lessons learned. We have seen with the external style sheet that blocks us. So what we want to make sure is that all these styles that we actually need, we want to make sure that we have them probably inlined. So everything that is critical and everything that moves things around on the page or colors them in a different color, we want to make these critical CSS rules inline so that we don't have to wait for the network to download them. Then also the order matters. So the tree can only be constructed efficiently if our order makes sense. If we are basically like moving things around all the time and then actually use JavaScript to reformat them weirdly, then that's actually really, really hard because then we have to kind of like reorganize things on the page later on. So yeah, also if you wanna do single page applications, what is really nasty is if you have some JavaScript that keeps pushing things into the DOM and changing the DOM around, because then we have to reorganize the tree all the time. JavaScript or the DOM tries to be clever, so if you're basically just going like, add this list item, and then add list this item, and then add list this item, and you basically just pile things on with JavaScript, the DOM will not actually make it happen immediately. It's going to be like, okay, wait a minute, maybe more, and that's perfectly fine, but you can actually screw that over by saying, add this list item, add list this item, add list this item, and how many items do I have now? And then the DOM goes, oh shit, and actually like assembles the list and goes, okay, 5. Okay? And then you go like, here's 5 more. And like, all right, okay, I'll wait if there's more coming. How many do I have now? What? Oh god, okay. And then you put the tree back together. That's called layout thrashing. Really bad idea. Yeah, also, if you have the possibility, do server-side rendering. I know that most of the frameworks can do it these days because basically you then get the advantage of having HTML being parsed as it was received, rather than having to wait with an empty list until JavaScript fires and then have to like cram everything into the DOM. So try to make use of this progressive DOM building and tree building that the browser comes with. You can write a lot of JavaScript code to make this slower, but I don't see why you should, right? That's what some sites do. So now we have all these tree things, and now we have to figure out how large is everything and how does it fit on the page. And that's literally what the layout process does. It doesn't actually paint in the pixels. It just goes, so we have an H1 with this text, so it's like this large, and it's an H1, so it pushes everything else in the next line, unless there's CSS. And basically it figures out where the boxes go on the screen. But as you can see, that's quite a bit of effort, right? It has to like build the tree, and as it builds the tree, it figures out, okay, this has to go there, this has to go over there, and then it like pushes things around. So that's pretty expensive. But it's done relatively efficiently for how expensive it could be. This is how it looks. So here we have a class box div with some text. And the browser goes, this is a div, so it takes the entire width, and we'll be good. But then we have some image, okay, we don't have time, like we don't have space to put it in the same line as the div because the div takes the entire width. So we're putting the image below it, and we'll be happy. Happy, wonderful website. This looks more like something that we might actually see in the browser. But then it goes, wait, there's CSS here, and it says that the box is actually inline block and it's only half the width. So we are cutting off half of our wonderful box that we created beforehand, and then it's like, okay, wait a minute, now we have like space for the image, so we're removing the image where it was and moving it to where it can fit. And and then we kind of like end up with what the layouted page looks like. So that's the layout algorithm. So basically we're figuring out how our page looks in terms of layout, not in terms of content, right? Okay. We do this based on CSS and object model and document object model. That means whenever you're changing that significantly with JavaScript, you have to redo this. And depending on where in the source you're putting your things, that might be more or less effort. Also, we are figuring out how large things are at this stage. So as long as you're changing certain things, let's say, for instance, color. If you change the color with CSS or with JavaScript, you change the color of an element, that doesn't mean that it grows, right? So at least our layout kind of stays the same if we change the color of an element. So if we are making something blue, that doesn't mean that it gets larger, right? And that's convenient because that means that we can skip the layout stage and actually we only have to repaint things. But still, it's pretty expensive, so you want to make sure that if you're changing things around, you're not affecting layout, because relayouting is expensive. Yes, and also if you change things, like if you make things larger, for instance, if you resize an image, then we have to repaint pixels, and that's also really expensive. Also, if you're animating things, well, right? If you're unlucky and if you're not careful, your animation pushes things around on the page and then bad time because we have to lay out again. So let's talk about painting. Here I'm painting a wonderful happy face. You have no idea how long it took me to make this GIF. I'm really bad at graphical design, you might have noticed from my slide design. So what is a pixel actually? Well, a pixel, as you might know, is basically 3 lights that are more or less bright. It's red, green, and blue, RGB. We have heard this before, haven't we? So basically what we want to do is we want to figure out how to write into these lights to make them brighter or less bright to get all those different colors. And if we look at a screen like this, for instance, this is a very low resolution screen as it has 3 by 3 pixels. Basically what it is a large list, or in this case a table, of 3 values for each of these pixels, and these values basically mean how bright is the red light, how bright is the green light, how bright is the blue light. And depending on what values we're putting in here, we get different colors. Surprise, surprise. So rendering and painting in the end is nothing else than having a gigantic list of numbers and writing into this list of numbers. Now what's good about this list of numbers is that for each pixel, these numbers do not overlap. So we basically have 3 numbers for the first pixel, 3 numbers for the second pixel, and so on and so forth. So whenever I'm changing a pixel, I do not have to make that dependent on something else. It's not like, write this number only once the first pixel has been written because it's the same number for the second pixel or something like that. There's no dependencies between these numbers, which is convenient. Because that means that we can write them in parallel. We don't have to write them one by one, we can write them in one go. We can copy large amounts of numbers in the same time. And basically it's like this process. I can't stand this GIF. It's writing hello, but basically that's what Paint does. You're writing a bunch of numbers by putting them into this wonderful grid, and voila, you have something rendered. So that's what the browser now has to do for all our elements. Everything that will go on the page will have to be drawn like this. Well, not quite like this. It's not happening like someone's actually clicking on the cells and making them colorful. It happens in parallel, so that's pretty good. But still, it's a bunch of numbers, right? If you think about it, it can't be cheap to write this. If we have like a full HD screen, that's a lot of memory. That's 1920 pixels by 1080 pixels. That's a few million pixels, and then we have 3 bytes for each of these pixels. So that's more than fits on a floppy disk, for instance. And if you have an old computer that has a floppy drive, and you write a 1 megabyte file, you know that that's not going to be fast, right? And it has this hilarious melody that goes with it, like terrible. So even for 500 by 500 pixels, which is a reasonable size for an image, for instance, we have to write 750 kilobytes. So now imagine that's a video, and you have to do that like if it's a video with 60 frames per second, you have to do it with 60 frames per second, so 60 times a second. That's quite a bit of memory that goes through, right? So you want to make sure that you're not repainting for the shit of it. You want to make sure that your shit of it, that's like a technical phrase, it's not a swear word. I haven't been swearing on stage if someone's asking. Right, so basically you have to write a lot of data out, and you don't want to write a lot of data unless you really have to. So what you can do instead is you can composite things. So instead of having to basically like rewrite all the pixels, what you do is you paint them once, and then you keep them somewhere in memory. And then you just only copy the entire memory around real quick, because memory copying is relatively fast compared to actually writing new values into memory. So here we're having two what's called sprites. The browser calls these layers, but it's the same thing. So we have two images in memory somewhere. We have the background and the Nyan cat. And then what we do is we copy them, like we copy the Nyan cat over the background at some point. Then we copy the background again, and then we copy the Nyan cat at another position. And we don't have to like repaint all these pixels, we just move the numbers around a bit. So that's relatively fast. And then you get like this wonderful animation of a Nyan cat floating around in space, accompanied with this wonderful melody that I'm not going to sing right now. But it's stuck in your heads, I know that. But how do you combine these? How does that work? Have you ever heard of blending? Who here has heard blending before? A few people. Who here has used CSS blend modes for something? A few people actually have used them. That's really cool. Because the blend modes are basically the answer to the question, how are we combining them? Blending is nothing else than applying a shader to a bunch of layers. So we have these two layers. We have the background, we have the Nyan cat. Those are our two layers. Then a shader runs, which is a function. It's this code, and we know code, so we are feeling at home here. And then we get an effect of how the layers are combined. In this case, I probably just put them over each other and be happy with it, for instance. And this is how a shader basically looks in pseudocode. So you have a function that takes the x-coordinate, the y-coordinate of the output. So this is the coordinate on the screen that we're going to fill in. This is the pixel that we want to write. Then we have a bunch of layers, which is basically a bunch of numbers as well as a bunch of colors. We have a blend function and a filter function. And then we call the blend function on all these layers for this particular position. So for instance, if you have a single layer and that's blue, you basically say like at position, for instance, 10, 10, I have this blue value here, and then you take that out and you'll be happy with it. But depending on how the blend function combines them, this color might change. For instance, it could be a grayscale blending or a filter that actually also just like takes whatever value came out of this. So basically blend and filter are more or less the same thing. You get a bunch of colors in, and then you mix them in a way, and then you get one color out, right? The difference is that blend works with like a bunch of layers, and filter only takes one color and changes it in one simple way. So there's different functions available for this blending. For instance, there's the screen blend. Looks complicated. In my opinion, it's not really clear what it does, but it doesn't fucking matter. Fucking is also a technical term. It doesn't actually matter, because basically all we want is we want to have it look like this. It's a blending way. We can blend with something else. We can blend with multiplication. We can just take the first color as a number and multiply it with the second color, which is also a number. So we multiply two numbers. That's not very complicated. That's a very simple blending mode. And it gives us this effect of where a darker thing is in the background, the entire outcome is going to be darker. Like black, for instance, is counted as 0, so whatever we are multiplying with a black line of the Nyan cat is going to turn out as 0. The white shining in the eyes is coming out as the blue that we had originally, because it's basically multiplying by 1. So we can just use any of these equations. There's like 16-ish equations in CSS. And then we basically get this blended color, and then we run another function over it. There's a bunch of them available. Those are the ones that are available. We can make it grayscale, we can blur it, we can change the contrast, all that kind of stuff. We can make it sepia, we can have a drop shadow, all these wonderful filters. And if you look at, for instance, grayscale, all it does is it takes 3 numbers, which is our color that came out of blending, sums them together, red, green, and blue, and divides them by 3, and then uses that for the 3 outgoing numbers. That's grayscale. So if the numbers were pretty large that came in, pretty bright color, then we're going to get a pretty bright gray or white. If there were pretty small numbers, then this is going to be a pretty small number in the end, so it's going to be a pretty dark gray. This is how this actually looks like. I thought if this is a hardcore session, then I'm going to show you some GL code. So this is what the grayscale function could look like, for instance. So we are taking the layer that we are looking at a coordinate s and t, and then we add them together, we divide them by 3, and then we use them as the outgoing color vector. Who here has done OpenGL or WebGL before? Okay, I lost most of the audience at this point. Okay, that's fine. No, I mean, this is basically how it works under the hood, but you don't have to worry about that unless you're really into writing WebGL code. So basically, compositing allows us to keep the different parts of our website, the different elements, separate, and then just put them together in different positions. And that's pretty fast, because we don't have to repaint all the pixels. Also, it's a really fast operation because it's just memory copying. And memory copying is something that actually the memory buses today are really optimized for. So that's fast operations. And some transformations can be done that way. For some transformations, we don't have to repaint. As I said, if we change the color of an element, that's bad because we have to repaint the color, right? We have to repaint the pixels in a different color. Damn it. But if we want to make it grayscale, then we don't necessarily have to repaint every pixel. We just change the way that we are blending and filtering, so that's an easy one. But there's other operations that we can do as well. So translate or move is rather easy. It's just we are copying the data at a different position. So that we can do in composite only. Then we have scale. That's a bit surprising, maybe, but actually, basically what you're doing is you're just reading multiple pixels multiple times, like a single pixel multiple times, or just not at all. So if you're scaling down, you're just not reading all the pixels. If you're scaling up, you're reading the same pixel multiple times to actually make it appear more often on screen. Same goes for rotate. You're just multiplying the values with a rotation matrix, and then you are ending up with a composite-only motion or change. But as I said, for each layer, we are keeping a piece of memory somewhere that we can copy from. So every element that we are having as a layer or a sprite is going to be in memory basically a second time, not only where it is, but also off screen where we can take it from. So don't make everything into a layer because you're actually running out of memory on mobile phones really fast. So basically, to avoid having a gigantic memory overhead, I mean, we all know that certain browsers really love memory, right? I'm not going to name any names. But still the browser is going to be like, nah, I'm not going to take everything into a layer because that means that I'm spending more memory than I probably should. Because not everything is going to be animated, not everything is going to move around, not everything is going to change and has to be composited nicely. So basically, the browser goes, I'm going to be conservative and I'm only making layers where it makes sense. And then it has to do a lot of guesswork. So video and canvas makes sense to be a layer because it's hopefully or most likely going to be changing all the time. A video is changing as the moment it starts playing, it changes every frame anyways, right? A canvas where we probably play a game or something is also probably going to run at 60 frames per second, so it makes sense to have these in a separate location because then when they stop like moving, then I can just composite them over, or if the canvas is moving, then I can just composite them over, and I don't have to like, you know, reflow everything and repaint everything all the time. 3D transformations, because 3D transformations can pop out, like you have the translate Z that goes into or out of the screen. So I'm going to make a layer for them as well, but only for 3D transformations. If it's a composite-only animation, this is a bit confusing. Why it's not like, what is a composite-only animation now? Well, we have established translation, so moving around, rotation, and scaling is definitely composite-only. And even if it's a 2D transform, if it's in an animation, the browser goes, ooh, I'm changing this a lot of times, because hopefully at 60 frames per second, I'm going to change it for a certain amount of time. So I'm going to make this hardware accelerated and make it into a layer, and that means that I can only composite it to a new location. So everything that can be done in a composite-only way, in an animation will be in a separate layer and will be composite-only. And then we have this wonderful new property, which has decent support these days. It's called will change, and we can specify what we will be changing a lot. So for instance, we can say, will change opacity. So that means, oh, make this into a layer because you can then composite it when I change the opacity. Will change left. So you know the left property is really bad for animations, right? Yeah, that's terrible. Not necessarily, because if it's absolutely positioned, so it doesn't actually affect the layout of the page, and it is in a will change left, then the browser knows, so this person is probably going to be moving the position, the left position of this element a lot. So what I'm going to do is I'm going to make it into a layer and then just pretend it's a translation. And that's actually pretty nice because that gives us these wonderful, smooth 60 frames per second. Let's play a game. Everybody wake up. Good morning. Все хорошо? Очень хорошо, конечно. Давайте. So we have this wonderful code here. It's a bit of CSS that says transform translate x 150 pixels. So it moves the element 150 pixels over to the side. And then after 2 seconds, we are changing it using JavaScript, and we are transitioning it, translating it back to 0. Will it paint? Do you think it paints? Who here thinks it paints? I'm bringing back the code. Who here thinks it paints? Oh, lovely. That's new. I'm not sure why it does that. I have opened the slides ages ago. That's wonderful. That's also a performance problem, huh? Давайте. Хорошо. It paints! The green flash means it paints. Доброе утро, как дела? Вы слушаете? Да? Хорошо. It's a 2D transformation. Translate X is a 2D transformation. There's no animations involved. It does paint. The green rectangle means it has painted these pixels again. So there was not a layer involved. It was in the same layer. It has repainted all these pixels. All right, let's try this again. Slightly different code. Basically doing the same thing, just with a different translation. Will it paint? No, нет. Хорошо, молодец. It's not gonna paint because it's a 3D transform, and 3D transform means we have moved this into a separate layer and everything will be fine. Давайте. Что это? Это говно. So this is another technical term, or the same. I'm not sure if I used that technical term. This is shit, right? This is terrible. You can't do this ever, ever. I mean, holy shit! What is he doing? Like, don't hold your pitchforks and torches for a second. Because you know what? What if I told you that I can totally change my game by using will change here? So now we have this animation for 2 seconds. And there's will change left. Молодец, да и нет. Who thinks that's a good thing? Who thinks that's a bad thing? Who thinks it depends? It's the classical answer, right? That's like a trick question. So the question, will it paint, is not in this case. That's pretty good, but what I'm not showing you here is that only works because the element is positioned absolutely. So it depends in this case, right? Because I didn't give you the full information. This only works if it is positioned absolutely, because in that case it can't flush everything else around it. If I'm making it position relative, that means if I move it around, it will push other things over the page, and that means that it has to be repainted. So in this case, this is a it depends answer, as the little dragon basically tries to say. Hi, little dragon, I like you too. There's practical examples. So here I built a simple thing, and as you can see, it's positioned absolutely. It doesn't push the other things around. I'm having a backdrop element there that creates the blur effect and makes everything a little darker. And as you can see, no green paint flashing. Well, the buttons, because the buttons have these weird hover states, but besides that, no green flashing. So you can actually use it outside of very simple, stupid examples. This is a sidebar example that you probably have seen more often than, I don't know, me. So lessons learned here are really avoid forcing the browser to do painting and do relayouting all the time, because that's expensive and it's going to make things much, much slower. Layers can help you with that. However, you want to make sure that you're not risking too much, because if you're risking too much in terms of creating layers where you don't know if you need them, then you're actually exhausting your memory. And the problem with that is you have no idea knowing when you're over memory capacity, and on mobile that's relatively soon, and things get really slow, because if you have to move memory between the GPU memory and the main memory, that's a slow operation, so actually it makes things worse. Always measure first. Measure, build your animations, be happy with it, see it repaint. The DevTools have this wonderful, I can show you. The DevTools have this wonderful little thing where you can, I'm not sure if that was a clever idea of making a new tab now, but we'll see. So here we have, you saw that? You saw the flashy thing? That was because I have repainted as the page was entered. So if I change the geometry of the page, which I should be able, if I'm saying responsive here, then it has to, you see that it basically starts repainting all the things, because now, as the page gets smaller, it has to repaint the elements as well. So, but this is not repainting. Very good. The button, for some reason, does repaint, even if I'm not triggering the button, but it's okay. And you can enable that by going into your DevTools and enabling, I think it's like in advanced or something, and rendering is enabled down here, and then you can do like paint flashing. So if I disable that, I don't get these wonderful flashes anymore. If I enable that again, then you can see that the button has this weird green, oh, that was a weird one. Ah, it's a browser bug, I think. We just hit a browser bug. That's an interesting one. There's no real reason for this to actually cause a repaint, but that's okay. I'm taking it. Browser, I have your back. I'm okay with it. You can also have like an FPS meter, so here you see how we are doing in terms of frame rate, and here you also see how we are doing in terms of memory. So for this relatively simple page with a bunch of images, we are taking 11 memory, or 10.4 megabytes right now. So that's quite a bit of memory already. If I would make everything into a layer, we would probably consume a lot more. Good. Sure. Where are my slides? I don't know. I'll find out. That's the wrong browser window. That's cool as well. Please come back. Uh-oh. All right. It's loading. So be careful with creating layers. Use the DevTools to figure out how you're doing these. Other browsers have these in the DevTools as well. Not necessarily the paint rect flashing, but at least they tell you when they're painting. And if you see a lot of paint events, you know why your page is slow. Try to make it composite only whenever you can. You can use the will change property for that. You can use the translate Z hack for that 3D transforms instead of 2D transforms. So you have a bunch of options to make these composite only and skip a bunch of the pipeline. Remembering the pipeline, this is how the pipeline looks like. We are receiving HTML and CSS. We are parsing it into the DOM and CSS object model. Then we are layouting them to actually fit certain page criteria. Then we paint each of them, and then we composite them together. And if you can, you want to have your animation skip all of that jazz and straight go for compositing, just moving things around rather than layouting them or actually repainting them. Sometimes you can't. That's the sad truth. So to summarize, you want to definitely make sure that your critical content, which is the content that the user sees first, is as static as possible and can be inlined without having all the additional network requests, because each network request takes a little while, and that means that the first flash of content will actually be later. So time to interactive is going to be important. You want to make sure that if the user is using your page, it doesn't cause lots of layouts and lots of troubles by repainting everything, because that's expensive. But that doesn't mean that you make everything into a layer, because layers are dangerous to play around with unless you know what you're doing. It all boils down to this. Before doing anything and before optimizing anything, measure. See if it's a problem. If it is a problem, improve it by the techniques that you learn, and you can see online. There's lots of materials on how to actually not have things relay out and repaint all the time, for instance. And the best thing that you can do is do less. Because the best work, or the fastest work, is the work that you avoid. And Paul Lewis summarized this really nicely. Performance is the art of avoiding work. It's a fine art, though. Right? You can quote me on that. You can quote him on that. He likes it. Arrow twist on Twitter, just saying. There's a bit of a bonus round, because I think I still have time. No one's shouting at me, so I guess I have time. Let's have a look at Canvas 2D and WebGL, because you know, Canvas is a layer, so everything's going to be fast, right? And we can like do all sorts of crazy things, and obviously WebGL is only for 3D graphics, and we only use it when we do complicated 3D things. Let's have a look. So I wrote a little test case. Imagine that we're having a canvas that is the full size of an HD frame. So it's the full screen basically on 1080p. So 1920 pixels, 1920 pixels wide, 1080 pixels high. Then we are positioning a bunch of objects at a random position, give it a random size, and then we draw that an image multiple times at these random positions and random sizes. So that shouldn't be too complicated. Let's have a look. So here we see on the y-axis the frames per second, and on the x-axis the amount of objects that we're going to do. So it's the same image being painted 1 time, 100 times, 250 times, 500 times, 1,000 times. And this is with Canvas 2D. This code performs like this on my MacBook. Well, if we look at that, the green line over there means that we are running at 60 frames per second. That's really good because that's really smooth. No matter what we are doing, we are being as fast as the browser lets us be. The orange line, 25 frames per second, that's like, yeah, that's fluid, that's all right, that's okay. But if we do more, then we're going to drop below that, and then it's going to be not so smooth and not so nice. And generally, like 25 frames per second is not that great. And then we have like 15 frames per second. That's probably the limit of what we perceive as a fluid motion. So after that, we basically see a slideshow. So, and if you see these, then that means that with 100 objects, with 100 times the image, we are already dropping far below the 60 frames per second. And with 250, we are already below 30 frames or 25 frames per second. And then let's not talk about 500 and 1,000 objects. So yeah, the web is slow. It's terrible. I'm very sorry. We unfortunately have to quit this entire web thing and just build native apps again because, you know, they're so fast and so nice. And I don't think so, because we have this other technology that's called WebGL. And I mean, this is really simple code, right? Don't read that, because, you know, I really tried my best to fit it all on one slide. Actually, this is even if you really did do the job of reading this, you might notice that this is actually a lie, because this is just painting a single triangle in white. So yeah, let's not talk about that. But it's the complete code, so that's pretty good for a white triangle. Maybe not, right? So don't try to read that. I have the code online somewhere that you can check it out later. But it gives us this. So even if we draw the image in WebGL and we, you know, have all the things that we need to make the same thing as we did in Canvas 2D, then what you can see is that we are not really giving a damn about how many objects we are having, right? So like we are sailing smoothly at 60 frames per second even for 1,000 objects. Now, people are people. So I got a wonderful question. And it's always men asking these questions, like, what the fuck is wrong with us? Also, what the fuck is a technical term, obviously. So, moving swiftly on, people are like, yeah, that's very nice, but you know, maybe what if you use Canvas 2D that is hardware accelerated? Okay, sure. We are doing better in that case. So, we can actually render 10,000 objects or 50,000 objects. That's not a problem. The problem is that, yeah. So the WebGL with 10,000 objects gets at least 20 frames per second, so that's not great, but it's pretty okay, I guess. But if I compare that to the 7 frames that I get in Canvas 2D, that's not really great. And at 50,000 frames, I mean, it's anyways a slideshow, but at least it's a faster slideshow with WebGL, right? It's nearly twice as fast. So yeah, my answer to that is, yeah, you can do that if you want a floating helicopter in your room that is really hot. It's like, I mean, go to Siberia, very cold winters, right? Probably a good idea to render 50,000 objects with Canvas 2D, but maybe not, okay? So definitely it's worth using WebGL for 2D content as well. Now the problem is that a bunch of people then go like, awesome, so I'm not going to make everything into WebGL. Because it's fast, right? I have the fastest DOM because I have like WebGL everywhere. And I'm like, no, that's a really bad idea. And then people are like, but why? Like, I made all this effort. I mean, you know how much code you have to write for that, right? So why do you say it's not a good idea? Well, because it's the wrong tool for the freaking job, okay? But the one amazing thing about the web platform, in my opinion, is that it gives us a lot of things for free. We don't have to build them. So I remember when the iOS developers in a previous job that I worked in went bananas when the iPhones, was it 6XL? The first one, there was an iPhone at some point in the history of the iPhones where there was the small version and the large version. Was it the 5? Was it the 6? 5,000 years ago, nobody cares, right? Okay, cool. Anyway, so there were 2 screen sizes, and the iPhone developers were like, 2 screen sizes? What? How are we gonna ever make this work? And everyone working for Android or the web went like, what? 2 screen sizes? That's cute. Have you heard about smart fridges? And the cool thing is HTML and CSS is precisely that. It responds to whatever the device can do, and you get a lot of affordances as well. A button behaves like a button, no matter if you use it with a keyboard or with a mouse or with a screen reader. The screen reader will read out button, yada yada, and then you can press it and you can tell if it's pressed or not. So we have these semantic content available by definition. We don't have to do anything. We don't have to work to make that happen. In WebGL, you have to rebuild all of that from scratch. So you are basically throwing away a lot of free stuff that the browser gives you. And also you have to reinvent all the UI primitives. WebGL doesn't know the concept of a click, right? So you have to figure out, where's my mouse cursor, what happens when I click this? A browser knows, oh, there's a mouse cursor over the button, and when this click happens, then I do something about it. So use HTML and CSS for semantic and accessible content and for your UI primitives. Do not reinvent it in other technologies, please. SVG is also really cool if you want images that respond and scale well. So our example case of like, make this image scale, that's something that SVG is literally made for. So it's even easier for the browser to make that efficient and fast. So if you have like declarative animations, so if you want to, I don't know, have a loader with like a gradient that changes or something like that, use SVG for that. It scales to any screen resolution and it's really fast and nice. If you can't use any of these, and you have like custom 2D shapes and you want to do some really simple graphics, I don't know, maybe a video thing that, you take the video, you draw that on a canvas and resize it or something, probably go for Canvas 2D. But if you're, for instance, building games, it is reasonable to actually go for WebGL in that case, because even if it's a 2-dimensional game, you get more direct access to the graphics pipeline, so basically you can skip the compositor and the skier, for instance, for Chrome. I'm not sure how it's called in Firefox. So basically, you skip a layer of abstraction and basically more or less go directly to the graphics hardware, which is nice, or the OpenGL drivers, which is nice. So don't use one tool just for the sake of it. Always make sure that the tool fits the purpose that you're trying to build. And with that, spasiba, I'm done. And I know that we have 15 minutes for questions, so I was a little faster than I thought. Any questions? Oh, there's a bunch of questions. Do you have microphones for people? Yes, хорошо. Давайте. All the questions everywhere.
Hello, Martin. Thank you for your speech. I have one little question. Should I avoid putting will change to the conservative elements like canvas, 3D transform, video to force it being layered?
Right. So should you avoid will change with elements that are already a layer like canvas and video?
Yeah.
No, because you get, I don't think it makes much of a difference for a layered element like canvas. I haven't tried it, to be honest. But I think it doesn't hurt either, because the more hints, it is a hint to the browser rendering engine. So basically, if you say, I have this canvas, and I'm gonna change how I'm gonna position it, or how I'm gonna size it, or how opacity, or what opacity I'm using, that gives a hint to the browser engine, and it probably is basically putting it on the fast lane. So I highly recommend doing that no matter what.
Thank you.
You're welcome. He has been raising his arm for 5 million years now. Give that man a break. Здравствуйте.
Здравствуйте. Спасибо for your talk. I wanted to add a fact that you said that animating top left or something like that causes no repaint. I just wanted to add that it's actually a browser-specific optimization, and it is not guaranteed to work in every single browser. And even in Chrome, it's not guaranteed to work every time. For example, if you have shadows or gradients, it is probably going to repaint, or semi-transparent elements. So it's actually not guaranteed. Therefore, it's actually better to use transparent.
I mean, okay,
even if
fair
it's
enough.
absolutely positioned.
It says example. For example, e.g.
I
position,
see.
absolute position. You're right. As I said, it is a hint at the browser. Firefox, as far as I'm aware, does not support it properly just yet. They are working on supporting it.
Yes.
So it's a matter of it's right now. It is a browser-specific thing, but it is a standard specification that is going to land in other browsers as well. And yes, you can't be sure that it's going to be hardware accelerated, as in it's not going to necessarily be composite only. True, it is a hint at the browser. I should have underlined that it's a suggestion to the browser to make it composite only. Yet, I got to say that I also said measure and then optimize based on what you've got. So always measure first.
Yes.
But thanks for that. Is that an actual question as well, or was that just a remark?
It was a remark, but I have a question as well.
Давайте.
I would like to ask, do different browsers use blending functions similarly? Are they basically the same in different browsers?
Yes and no. So they use them similarly. It's just a question of, so for instance, the only browser that has finished their rewrite in terms of architecture to actually make them composite only for, it's complicated. Okay, it's complicated. Browsers, filters and blending mostly work the same in all the browsers. However, Chrome is the only one that has refactored their architecture for rendering so that they are composite only. But that's only true for some of them, and that's only true for them in CSS filters. So SVG filters, for reasons that I don't understand yet, do repaint. So they always repaint. So if you use an SVG filter, great, but it's going to be repainting for some reason. All of them repaint in other browsers. So Firefox, Safari, Opera, no, Opera not, because they are using Blink. Safari, Internet Explorer, Edge, all of them repaint, unfortunately. But that's not because it can't be done, it is because the architecture isn't made for accelerating them.
So right now we should expect different behaviors of blending in different browsers.
Yes, unfortunately, yes.
I see, thank you.
На ничего? Is that the right Russian phrase? Не знаю, я плохо говорю по-русски, извините.
Great. So, back in 2013, back in 2012, I was really making this all animation just with Adobe Flash, and we just imported all of this Flash animation to the web page. But right now, we had to switch to all of this SVG animation to the canvas and all of this stuff. But this works slightly worse, slightly slower than Flash, and it's already 2 or 3 years since we have done this, and I still don't see any improvements of the of this technology.
Okay.
So how do you think? Will we ever see any changes that will let us do all of that impressive animations that we have done before? Mm-hmm. But will we be able to do this in future, in close future? with just Canvas or Webgl?
Yeah. Yes.
All right.
Very simple. So will we be able to do like all the animations that we did in Flash and other things fast on the web in the future? Yes. First things first, I don't think that you saw no improvements, because certainly if you use filters or blending modes, they are now accelerated in Chrome since 2014, I think, or 2015, I'm not sure. So that's definitely a huge improvement. And there's lots of work going on actually refactoring the rendering pipelines in all browsers. Probably the best precursor of what's going to come in the future might be Servo. Servo is an experimental browser engine built by Mozilla. It's written in Rust, and it basically uses GPU for all the things. So basically everything becomes more or less a layer-ish, if you want to say that, but it's complicated, but it's actually fucking fast. So in all the browsers, you get 60 frames per second as the maximum, and in WebRender, which is the browser engine in Servo, you get 100 to 120 frames per second already today. It crashes every now and then, but you know, that's an experimental browser engine, so don't worry too much about it. It's going to be better at some point in the future. They're working on that, and I think the lessons learned for them are also valuable lessons for every other browser vendor, so we will see an improvement in rendering speed just by GPUs getting faster, memory getting bigger, and browser vendors using these new challenges. I mean, the problem with the browser engines that we're having today is they have been built for mostly static websites and then have been like changed all over the place to accommodate these more dynamic graphic applications. And I think with like refactoring these the browser rendering pipeline, we're going to see more and more performance improvements in the future. We already saw big performance improvements in the past. If you compare that to something that is like, for instance, the browser engine from 2010, you're going to see a big difference already, even though it's not perfectly yet, right? We're not there yet, but we're getting there. I don't know how long that's going to take, to be honest. Yep. Oh my God, more hands going up.
Hello, Martin. Thanks
Hi.
for your talk. Nice to see you again, by the way. My question is about the measurement part. Are there any tools, or do you think it's possible to build them to statically analyze your animations, your style sheets, to find out if they're going to be slow, using compositing, using repaints, and whatsoever?
Yeah. So can we statically analyze the performance of our style sheets and stuff? I think so. First things first, you can totally see, like, there's already, I'm not sure about page speed insights, but I think they are working on integrations that tell you at least where you should enter a will change, for instance, or if a thing is not composite only, you can fix that. But what you can't do is, if you're using JavaScript to change that, that's really hard because it's dynamic, right? It's really hard to figure out if that's going to be fine. So we're never going to catch all the problems, I think, automatically. It's always going to be a bit of manual testing, I'm afraid. But I'm certainly sure that we'll have better tooling to figure out these bottlenecks in the future. I know that we are already working on things in Chrome and Firefox, so looking forward to see more of that land.
What kinds of things?
For instance, animation inspectors that tell you how often actually it paints, and there's also JavaScript APIs coming. So there is a JavaScript API already for performance. What was it? It finds scrolling jank actually, and basically tells you on how like the scroll performance was and all that kind of stuff. So we are getting more instrumentalization into the browser engine by hooks. There's also the user timing API that allows you to measure parts of code, how long do they take, and show them in the timeline. I'm relatively sure that we're also gonna probably at some point get compositor timings as well. And then you can get the compositor times, and then you can say, oh, look at that. I know that we have paint times already, so you actually can figure out, we are experimenting with this right now. So when we render a scene, we measure how fast we are rendering, and if that is too slow, then we disable things. That's the thing that we can do, for instance. If you see that your paint times for the animation are too high, you could disable them and just like have them flip or something. So yeah, we're getting better tools. It's just a matter of time, as always. But I'm absolutely sure that people would love contributions. Pull requests are always well received. Browsers need your help as well. And the dev tools, did you know that the dev tools for Firefox are written in React, and I think for Chrome as well? So if you know JavaScript, then you can write dev tools plugins. Highly recommend that.
Thank you.
You're welcome. There was like one person in the back like going furiously, I have a question.
Hey Martin, thanks for the talk. Maybe it's a little bit outside of the scope of the talk, but can you move to slide where there was Webgl, Canvas, and like these blocks?
Sorry, I moved in my slides. I didn't notice.
Oh,
This or
like boxes?
boxes?
Yeah.
Like this?
No.
Or you mean this?
But whatever.
This.
I mean, like if you compare native with web and if, for example, right now we have React Native and this kind of thing, we can sometimes build good experience with Canvas, but what are limits like? And there is always a problem with native gestures, like how to emulate, like even if Webgl gives us a lot of frames per second, we're still, it's kind of tricky to emulate our gestures of native. So, what do your thoughts on that? Where we should go web or just go native?
The answer is, as in the second round, or was it the third round? I think it was the third round of Will It Paint. It depends, which is the non-answer I can give. No, the real answer is it depends on your use case, obviously. But I personally have not seen gestures being a problem in the mobile web anymore, because browsers have gotten a lot faster. Unless you have like Android 2 point something, then that's still a problem. But I think there's not much going to happen about that. Touch gestures have been getting faster. WebGL is fast, but yes, you have to emulate the gestures because you can't use them on WebGL natively. If you look at the gap, just not talking gestures or events or something like that, just talking WebGL, when it comes to draw calls, you're probably seeing a divide of 10, so factor 10. Native on mobile, you can do 10 times more draw calls than you can do in WebGL. And I'm not sure if that's ever going to close up, because there's still this one layer of abstraction that is in between the two. But as far as I can tell, with WebGL 2.0, for instance, a lot of architecture rewrites have been done. I'm not sure about Apple, to be fair, but at least for Chrome, I can say that they are now much, much leaner in how fast you get into the OpenGL pipeline, and then you are at the same level as a native application when it comes to WebGL. So, as you might have hinted at, the problem, the bottleneck might shift from actually rendering at 60 frames per second towards something else. And apparently we don't have time anymore. Yeah. But yeah, performance is getting better. I'm not sure if we're ever going to catch up with native, but I'm not sure if that's a problem, to be honest, right now. It was a problem 2 years ago. No more questions? No, нет. Это все. Спасибо. I'll be in the discussion zone. Hit me up. Thank you very much.